Hello, and welcome to Lab 3, Part C, Isostatic Adjustment. In Part B of your lab, you determine whether 4 different columns contained a similar amount of mass and therefore exerted a similar hydrostatic pressure at their base. If columnar masses were roughly equal, then these columns are considered to be in isostatic equilibrium and are relatively stable. Next, we will experiment by changing the isostatic variables of floating blocks by using an online program developed by Dr. Gary Gertie at San Diego State University's Department of Geological Sciences. Go to the online Isostatic program now by clicking on the link in your lab assignment. Make sure to allow flash animations and make sure to disable your pop-up blocker. Pause the video and open this website now. We will use this program to create 2 different models of lithospheric floating blocks. Located on the right, there are 5 separate areas that contain the variables for each block. Within each block, you will change the input variables that appear in red. These input variables include total thickness crust, density of mantle, and density of crust. After changing input variables, then you must click Calculate to update the results for each block. The resulting output data in the model will appear as thickness of crust riding above mantle and the visual depiction of each block in the graph. Model 1. For your first model, we will create floating blocks of continental crust of different thicknesses. The input variables will come from the table in your lab assignment. Once you input the given variables, click Calculate and floating blocks will appear in the graph. For each floating block, point your mouse over the block and a hidden dialog box will appear showing the elevation of the top of the block relative to sea level. You use this data to answer associated questions in your lab assignment. Model 2. In your first model, you change the variables of thickness and continental crust. In Model 2, we will create floating blocks of different densities of oceanic crust. Again, the input variables will come from the table in your lab assignment, and once you input the variables, click Calculate, and floating blocks appear in the graph. Again, you will use this data to answer the associated questions in your lab assignment. Density. In your lab assignment, you'll need to explain why the floating blocks in your models behave the way they do. When you explain your answers, you'll need to answer in terms of density, mass, and volume, and as they relate to isostatic equilibrium. For example, what if you increased mass? Then if volume is held constant, density would also increase in direct proportion. It helps to think of the density formula as a 1-to-1 ratio, where 1 equals 1 divided by 1, or 1 equals 1, which is a mathematical equation in equilibrium. Thus, if you double the mass while holding volume constant, then you double the density. You can use this line of reasoning to explain your answers in your lab assignment in terms of the changes that occur in density, mass, and volume, and how they affect isostatic equilibrium. Let's take a look at a second example. What if you increased density and held mass constant? Then volume would have to decrease in direct proportion. Thus, if you double the density while holding mass constant, then you will half the volume. Again, use this reasoning to describe isostatic adjustments in terms of mass, volume, and density. It's now time to complete your lab assignment for Part C, Isostatic Adjustment. Once completed, watch Video 5, Part D, Connect Isostatic Equilibrium Observations, and please address your questions to your lab TA.